discussed in previous videos. You can check that. Question number 5. We have to derive these results from this Fourier series. First, we will solve the question as it is, and then we will put some values like x equal to 0, x equal to pi. Then we add those series, and then we get third series. So how can we solve that? Let's get started. How to solve this question? First, we will assume function equal to series. This is our first step. After that, we will apply Euler formulas. A naught is equal to 1 upon pi minus pi to pi fx dx, 1 upon pi minus pi to pi x square dx. Then we know that x square is an even function. If the function is even and interval is minus pi to pi, then it will change to 2, 0 to pi even function. So 1 upon pi multiply by 2, 0 to pi x square dx. Then we integrate this, we get x cube upon 3. What is the formula of x power n dx? Integration, that is xn plus 1 upon n plus 1. 2 upon pi x cube upon 3, 0 to pi. Then we put value of pi and 0 in this x cube upon 3, and we get 2 upon 3 pi square. So a naught value is 2 upon 3 pi square. You already know that in minus pi to pi, if the function is even, bn is 0. So we don't need to find bn. We will find a naught, an, then put a naught, an in this equation. Now we will solve an. An is equal to 1 upon pi minus pi to pi fx cos nx dx. What is the value of fx? That is x square. So the whole function is x square cos nx dx. We know that if minus pi to pi interval fx is even function, then the limit will change to 0 to pi, and outside of the limit there will be 2. Here x square cos nx is an even function. X square, if we put fx is equal to x square minus x square, we will get x square. So x square is an even function. Cos nx will also remain same after putting minus x. So x square is also even, cos nx is also even, and even function multiply even function is even function. So this whole function is an even function. This result you should keep in your mind, that even function multiply even function is even function multiply odd function is odd function, and odd multiply odd is also even function. Even, odd, even multiply, they will remain odd. So here we change the integrations from 0 to pi, outside of the integration to x square cos nx. Now we will do integration, first function, second function. What is the formula of integration? First function as it is, integration of second function, then take derivative of first function, and then take integration of second function. After integration, we get this whole bracket. For example, if we do integration of x square cos nx dx, that will be x square integration of cos nx dx minus integration of x square integration of cos nx dx. That will be x square sin nx upon n minus 2x sin nx upon n dx. Then we will do integration again, x square sin nx upon n minus 2x integration of sin nx minus derivative of x integration of sine nx dx. Then we get this. After that, we put pi and 0 values in this whole statement. After putting those values, we get this result. We know that cos n pi is minus 1 power n and sine n pi is equal to 0. After putting these values, cos n pi, sine n pi, we get this result. So value of an is equal to 4 minus 1 power n square. Bn is 0. We know that if the interval is from minus pi to pi, fx dx, fx function is given, then bn will be 0. If in question there is a function like fx is equal to x square and the interval is minus pi to pi, then automatically bn will be 0. X square if x square is an even function. We don't need to find bn. Now put values of a0, an, bn in equation 1. What is equation 1? That is fx is equal to a0 plus summation n1 to infinity an cos nx plus summation n1 to infinity bn sin nx. Bn is 0, so we will put a0 and an values here. Now we have x square is equal to pi square upon 3 plus 4 minus 1 upon 1 square cos x plus 1 upon 2 square cos 2x minus 1 upon 3 square cos 3x plus up to so on. How we get this series? When we put n equal to 1, 2, 3 in this summation, we get this result. Then we have to find result 1, 2 and 3. Now we put x equal to pi in second equation. Then when we put x equal to pi in second equation, then we get this result. Now after taking right hand side pi to left hand side, we get pi square upon 6 is equal to 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus 1 upon 4 square, and that is the third equation. That is result 1. We hence proved here result 1. Now we will put x equal to 0. We are putting values according to our assumption. You can put 0, you can put pi, and then you will get the result. It is hit and trial method. X equal to 0 in equation 2, we get this result. Then we take 4 to the left hand side. This is the second result. Here we proved second point. Now we will add third equation and fourth equation. This is the third equation, fourth equation. Now we will add third and fourth equation. Then we will get, this is third and this is fourth equation. Then we will get this result. How? When we add third equation, that is pi square upon 6 with fourth equation pi square upon 12 and 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus 1 upon 4 square with 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square. These values will get cancelled, and after taking LCM, we will get 3 pi square upon 12, that is pi square upon 4, and here we will get double of 1 upon 1 square, double of 1 upon 1 3 square. Now we will take 2 to right hand side, that is pi square upon 8. Here we proved third point. With this we solve this question. Now we will solve question number 6, that is find the Fourier series to represent the function fx is equal to mod sin x in minus pi to pi. You already know that if the interval is minus pi to pi, you have to check if the function is even or not. If the function is even, automatically bn will be 0. So the first step is let fx is equal to 1 by 2 a naught plus mission and 1 to infinity a n cos n x plus mission and 1 to infinity b n sin n x. What is the first step? That we already assume that the function is equal to the Fourier series. Then we will find a naught, a and bn, and then we will put a naught, a and bn in the first equation, and then we get the final result. We know that since fx is a fx sin mod sin x is an even function minus pi to pi, therefore the Fourier constant bn will have the value 0. We know that in the modulus function everything will get positive, so the function will remain even function. Like if we put minus fx instead of x, we will get same function as it is. We can write it as mod sin x also. So the value of the function will remain same in modulus function if we put minus x instead of x. So bn value will be 0 here. Now we will find the value of a naught, that is 1 upon pi minus pi to pi fx dx, 1 upon pi minus pi to pi fx, that is mod sin x dx. Now we will change the interval of integration. We know that mod sin x is in even function, then the integration interval will be changed from 0 to pi, and out of the integration there will be 2. So when we integrate sin x, we get minus cos x, and then we put values of 0 and pi here. And after putting values of 0 and pi, we get 4 upon pi. So a naught value is 4 upon pi. Now we will solve an, that is 1 upon pi minus pi to pi fx cos nx dx. And mod sin x, modulus sin x, we know that that is an even function. And cos nx, that is also an even function. We know that even function multiply even function is an even function. So here interval will also change, that is 2 upon pi 0 to pi sin x cos nx. Now we will multiply and divide by 2. So that will be 2 upon 2 pi 0 to pi 2 sin x cos nx dx. In this type of integration, we consider cos nx and n function, a function which contains n as a first function and other one second function. So now we will do integration here. Now we are going to solve the integration part, that is 1 upon pi 0 to pi sin n plus 1x minus sin n minus 1x dx. How did we get it? With formula, that is 2 cos a sin b. Formula is sin a plus b minus sin a minus b. We use this formula here. After that we did integration, and then we took LCM of these two terms, and then we get this n plus 1 cos n minus 1 pi minus n minus 1 cos n plus 1 pi plus n minus 1 minus n plus 1. And then we multiply n with cos n minus 1 pi, 1 with cos n minus 1 pi as it is. We bracket multiply here in this term. After that, we solve this term, and in the end we get 2 here. And here, by solving, we get n cos n minus 1 pi plus cos n minus 1 pi minus n cos n plus 1 pi plus cos n plus 1 pi n minus 1 minus n plus 1. N is not equal to 1. If n is equal to 1, this whole term will be not defined. Out of the bracket, there is 1 upon pi n square minus 1 by taking LCM of these two terms. by taking LCM of these two terms. 1 upon pi n square minus 1, n. We took n common from these two terms. Cos n minus 1 bar pi minus cos n plus 1 bar pi, we get it here. After that, we separate other terms. We get 2 from this term. And we know that cos A minus cos B, that is equal to 2 sin A sin B, and cos A plus cos B is equal to 2 cos A cos B. We use this formula here. After that, we get n point multiply 2 sin n pi plus 2 cos n pi cos pi minus 2. Out of the bracket as it is 1 upon pi n square minus 1. Now we know that sin n pi value is 0. When we put n pi value 0, this whole term sin n pi and sin pi value is 0. When we put value here, this whole term is 0. And now we get 2 cos n pi plus cos pi minus 2. 1 upon pi n square minus 1. 2 cos n pi will be 2 minus 1 power n. Cos pi is minus 1 minus 2. Now we know that n is not equal to 1. If n is not equal to 1, then it will be any other number. So we can't tell that what is the exact value of n. So we take cos n pi as it is in the answer. Now we took minus 2 common, minus 2 upon pi n square minus 1. We get 1 plus cos n pi here. We get 1 plus cos n pi here. Instead of minus 1 power n, we remain that term same, cos n pi. We get 1 plus cos n pi here. And when we multiply these two terms, 1 plus cos n pi with minus 2, we get minus 4. How we get minus 4? From this term. We know that 1 plus cos x, that is equal to 2 cos square x by 2. So 1 plus cos n pi, 1 plus cos n pi will be 2 cos square n pi by 2. So the answer will be minus 4 cos square n pi by 2 upon pi n square minus 1. For n is equal to 1, a1 is equal to 1 upon pi minus pi to pi mod sin x cos x dx. Now we know that sin x cos x is an even function, so interval will be changed 0 to pi. Outside of the integration there will be 2. 0 to pi sin x cos x dx. We know that if we put a pi into this, that this term will be 0. Why we find a1 here? We know that n can't be 1 in an term, as we already discussed, and the formula of the Fourier series is fx is equal to a0 by 2 summation n1 to infinity an cos nx. Bn is already 0. So we will separately find a1 here and summation n2 to infinity cos nx after that. Now we put the value of an that we found and then put the value of n2, 3, 4, 5 and we get the end result here.